Have you ever looked at a Wireshark capture and felt overwhelmed by thousands of packets scrolling across the screen? What if artificial intelligence could help you understand network traffic faster and identify suspicious activity more efficiently? In today's video, I'll show you how to use Wireshark together with AI to analyze network traffic in a cybersecurity lab environment. We'll build a realistic attacker-victim scenario using Kali Linux and Metasploitable, capture the network traffic, and later use AI to help us understand what's happening inside that traffic. Let's get started. Before jumping into the lab, let's quickly understand what Wireshark is. Wireshark is one of the most widely used network protocol analyzers in cybersecurity. It allows us to capture and inspect packets traveling across a network. Using Wireshark, we can monitor network communications, troubleshoot connectivity issues, investigate security incidents. However, one challenge with Wireshark is that packet captures can become very large and difficult to interpret. This is where AI becomes useful. Instead of manually reviewing thousands of packets, we can use AI to summarize traffic patterns, explain protocols, identify suspicious connections, highlight anomalies, help beginners understand packet data faster. Today we'll generate network traffic in our lab and capture it using Wireshark. For this demonstration, I'm using Oracle VirtualBox. Inside VirtualBox I have two virtual machines. Kali Linux, which will act as our attacker machine. Metasploitable, which will act as our vulnerable victim machine. This setup is commonly used for cybersecurity training, penetration testing practice, and network traffic analysis. This video is for educational and ethical cybersecurity training purposes only. All activities are conducted in a controlled lab environment. Do not use any techniques demonstrated in this video on systems you do not own or have permission to test. Unauthorized access is illegal. The creator is not responsible for any misuse of the information provided. Let's begin by starting our Kali Linux virtual machine inside Oracle VirtualBox. Once Kali Linux finishes booting, log in using your username and password. After successfully logging in, open a terminal window. Now we need administrative privileges to perform our security testing activities. To do that, type the following command: sudo su and press enter. This command switches us to the root user, also known as the superuser, giving us elevated permissions to execute administrative and security-related commands. After entering the password, you'll notice that the terminal prompt changes, indicating that we now have root-level access. Next, let's identify the network configuration of our Kali Linux machine. Type the following command: ifconfig, and press enter. The ifconfig command displays information about all available network interfaces on the system. Here we can see important details such as the interface name, IP address, MAC address, transmitted packets, received packets, and other network statistics. The most important information for our lab is the IP address assigned to Kali Linux. This IP address uniquely identifies our machine on the network and will be used later when communicating with our target system. Take a moment to locate and note down the IP address displayed for the active network interface. Understanding how to identify a system's IP address is a fundamental skill in networking, cybersecurity, and penetration testing because it helps us understand how devices communicate within a network. Now that we have identified the Kali Linux IP address and confirmed our network settings, we are ready to move on to the next step of our lab environment setup. Now that our Kali Linux machine is ready, let's move back to Oracle VirtualBox and start the Metasploitable virtual machine. Metasploitable is a deliberately vulnerable Linux system designed for cybersecurity training, penetration testing practice, and security research. Once the system has finished booting, log in using the default credentials. The username is msfadmin, and the password is also msfadmin. After successfully logging in, let's clear the terminal screen by typing the command clear and pressing enter. This gives us a clean workspace for the next steps. Now let's identify the IP address assigned to the Metasploitable machine. Type the command ifconfig and press enter. Just like we did on Kali Linux, this command displays network interface information, including IP addresses, MAC addresses, and network statistics. Locate the active network interface and note down the IP address displayed. This IP address will be our target system throughout this lab. We'll use it to generate network traffic that can be captured and analyzed using Wireshark. Now that we have identified the victim machine's IP address, our lab environment is almost ready. Before we begin capturing traffic, let's quickly understand the roles of the two machines in our environment. In this lab, Kali Linux will act as the attacker machine. This system contains various cybersecurity and penetration testing tools that security professionals use for assessments and testing. Metasploitable will act as the victim machine. It contains intentionally vulnerable services and applications that allow us to safely practice security testing in a controlled environment. Any communication between these two machines will generate network traffic. As the attacker interacts with the victim, packets will travel across the network. Our goal is to capture and analyze those packets using Wireshark. This allows us to observe exactly what is happening at the network level and gain a deeper understanding of how systems communicate. With both machines running and properly configured, we're now ready to start monitoring the network traffic. Now let's return to our Kali Linux machine and open Wireshark. Wireshark is one of the most popular network protocol analyzers used by cybersecurity professionals, network engineers, incident responders, and digital forensics investigators. Let's launch Wireshark. Once Wireshark opens, you'll see a list of available network interfaces. These interfaces represent the network connections that Wireshark can monitor. Depending on your VirtualBox configuration, you may see multiple interfaces available. Select the interface connected to your virtual network, where communication between Kali Linux and Metasploitable is taking place. Choosing the correct interface is important because Wireshark can only capture traffic that passes through the selected network adapter. After selecting the interface, click the blue shark fin icon located at the top of the Wireshark window. This starts the packet capture process. Immediately, you'll begin seeing packets appear in real time. Each row represents an individual network packet containing information about communication occurring on the network. At this point, Wireshark is actively monitoring and recording all network activity passing through the selected interface. As we generate traffic between our attacker and victim machines, Wireshark will capture every packet, allowing us to analyze the communication in detail. Now that Wireshark is actively capturing packets, let's generate some network traffic that we can analyze later. We'll switch back to the Kali Linux terminal and perform a port scan against our Metasploitable target using Nmap. Nmap, which stands for Network Mapper, is one of the most popular network reconnaissance and scanning tools used by cybersecurity professionals. In the terminal, type the following command. Nmap-s capital V capital A 192.168.1.17. And press enter. Let's break down this command. The -s capital V option enables service version detection. This tells Nmap to identify the software and version running on each open port. The -A option enables aggressive scanning. This performs operating system detection, service detection, traceroute, and additional information gathering. Finally, 192.168.1.17 is the IP address of our target machine, Metasploitable. Once the scan completes, Nmap presents a detailed report showing the services running on the target system. Let's review the most important findings. Port 21 is running FTP using Versus FTPD version 2.3.4. Anonymous login is allowed, which means users may be able to access the FTP server without providing credentials. This is generally considered insecure. Port 22 is running SSH. SSH provides secure remote administration of Linux systems. Port 23 is running Telnet. Unlike SSH, Telnet sends information in plain text and is considered insecure. Port 25 is running SMTP, which is used for email communication. Now that we've identified a web server running on port 80, let's perform web content discovery using DIRB. DIRB is a web content scanner that helps discover hidden files and directories on a website. In the terminal, type the following command. DIRB http://192.168.1.17 and press enter. Let's understand what this command does. DIRB takes the target URL and automatically tests thousands of common file and directory names against the web server. Its goal is to discover resources that may not be visible through normal website navigation. In our scan, DIRB generated over 4,600 test requests against the target website. Let's review some of the interesting findings. DIRB discovered a directory named /DAV. This is a web DAV directory that may allow remote file management depending on configuration. It also found PHP info pages. PHP info pages often expose sensitive server configuration details and should not be publicly accessible on production systems. Next, DIRB discovered a PHP myadmin directory. At this point, we have completed both our Nmap scan and our DIRB web enumeration scan. Throughout these activities, Wireshark has been continuously capturing all network traffic between Kali Linux and Metasploitable. Let's return to Wireshark and stop the packet capture. Immediately, we can see hundreds or even thousands of packets that were generated during our reconnaissance activities. These packets contain valuable information about every request and response exchanged between the attacker and victim systems. To focus only on traffic related to our target machine, we'll apply a display filter. In the filter bar, type IP.attr double equals 192.168.1.17 and press enter. This filter displays only traffic associated with the Metasploitable target system, making analysis much easier. Notice how we can now clearly observe the Nmap scanning activity, web requests generated by DIRB, TCP handshakes, service responses, and many other network communications. This is exactly why Wireshark is such a powerful tool for network analysis and cybersecurity investigations. Now let's export this captured traffic for further analysis. Navigate to File, then Export Packet Dissections and choose CSV format. Save the file to the desktop. The CSV file contains all the packet information collected during our testing session. Next, we can simply drag and drop the CSV file from Kali Linux to our Windows machine using VirtualBox file sharing features. Now that we've exported the packet capture as a CSV file and transferred it from Kali Linux to our Windows machine, let's use artificial intelligence to help analyze the traffic. Open your web browser and navigate to ChatGPT. Next, upload the CSV file that we exported from Wireshark. Along with the file, we'll use a specialized analysis prompt, which I'll include in the video description below. This prompt helps ChatGPT understand that we're analyzing network traffic from a cybersecurity lab environment. Once the file is uploaded and the prompt is entered, click Enter and allow ChatGPT to process the traffic log. After analyzing the file, ChatGPT provides a summary of the network activity that occurred during our lab exercise. Let's review the results in simple terms. Hash finding 1, port scanning activity detected. ChatGPT identified a large number of TCP/SYN packets originating from 192.168.1.15 and targeting 192.168.1.17. In simple terms, this means one machine was knocking on many different doors of the target system to see which ones were open. Remember in our lab, 192.168.1.15 is the Kali Linux attacker machine. 192.168.1.17 is the Metasploitable victim machine. The analysis found more than 1,000 scan attempts across many ports. This behavior is exactly what we would expect when running an Nmap scan. So ChatGPT successfully recognized the reconnaissance activity we performed earlier. Hash finding 2, multiple open services discovered. ChatGPT also identified several open services on the target machine. It also correctly identified Kali Linux as the scanning system. This demonstrates how AI can quickly recognize patterns that would otherwise require manual analysis. Hash finding 4, service enumeration activity. ChatGPT also detected activity related to service enumeration. Service enumeration means gathering additional information about services running on a target. Hash finding 5, external DNS traffic. The analysis also identified some communication with an external IP address. However, ChatGPT determined that this traffic consisted primarily of DNS reverse lookups. These lookups are used to translate IP addresses back into hostnames. This type of activity is very common and generally considered normal network behavior. Most importantly, ChatGPT did not identify this traffic as malicious. Hash overall security assessment. At the end of the analysis, ChatGPT summarized the overall activity. It correctly identified the traffic as reconnaissance activity. Reconnaissance is the first phase of many security assessments and penetration tests. The traffic clearly showed port scanning and service enumeration. In a real production environment, such activity would likely be considered suspicious and would trigger security alerts. However, in our cybersecurity lab environment, this behavior is completely expected because we intentionally generated the traffic for learning purposes. Hash why this is useful. This is where artificial intelligence becomes extremely valuable. Instead of manually reviewing thousands of packets, AI can summarize network activity. Feel free to download the packet capture, follow along in your own lab environment, and experiment with different types of network traffic. Thank you for watching, and I'll see you in the next cybersecurity tutorial.